Our learning targets for this specific video is all about slopes. So the first thing that is noted in here is rewriting a linear equation in two variables from the form ax plus by is equal to c to the form y is equal to mx plus b and vice versa. Meaning to say we're going to have linear equations in the form of the standard form and linear equations in the form of the slope-intercept form, which will be introduced in this video. So our goal for the second learning target is to illustrate the slope of a line given 2 points, equation, and or the graph. So we will have different situations wherein we will be identifying the slope given three different situations. And we're going to maximize those concepts in order for us to apply that skill in graphing and plotting of points. So let's start with our first concept, which is the slope of a line given the graph. So the slope of a line can be said as something that we can relate to in real life, where are there things like when you're walking or cycling, which there are some roads that are easier to move past or compared to others. So when we say the steeper the road is, the harder it is to walk or cycle ahead. This implies that when a road is steeper, it's the higher the way it's elevated. It's a much different. This is an actual application of linear functions or equations in real life. And again, for today's session, we will illustrate and solve for the slope of a line given the graph, equation, and then 2 points. Let's start with the graph. So it's important to take note that the slope of a straight line given its graph is the measure of the ratio of the vertical change to the horizontal change, which is what we call as the run. Since we mentioned the word ratio, this can be represented through a fraction. So slope is equal to the vertical change over the horizontal change. Since this is a bit difficult to remember the longer terms or vertical change, horizontal change, we can put it in simpler terms, which is rise over run. The rise implies the vertical change and the run implies the horizontal change. In this case, to better understand the concept of rise over run, let us have an example of a graph. As you can see here, there is a straight line and 2 points that lie on that mentioned line. So in this case, in order for us to get the slope of the given, all we have to do is to find our certain starting point. And this is an important thing for everybody to know. It doesn't matter what point you start with. What matters is if you know the sign of your movement. So I'll explain that better in this one. So let's say that I will start with this point right here. And our goal is to go to the next point, which is right here. So in order to do that, we only have two movements. It's either we rise or we run. So let us start by rising. So from this point right here, let's go 1, 2, 3, 4, 5, 6. So this implies that we ran for 6 units. Then, sorry. We rise 6 units. Sorry. Then we run how many units from here on out? We simply run by 1 unit from this point on to here. So that means that we have the following: rise equal to 6 and run equal to 1. So to get the slope of this straight line, all we have to do is to apply the formula rise over run, and this will give us 6 over 1, and that is also equal to 6. So this is our slope for this given. And if you look at the guide questions below, it's asking us, is the slope positive or negative? I guess it's pretty much straightforward in here that our slope is indeed positive. It's straightforward naman. There's no problem with that. Now, as you can notice, there's a question: is the line going upwards from left to right, or is it going downwards from left to right? So we only have two sides here. This is the left side, and this is the right side. So we're being asked if the straight line is upwards or downwards. It's easy to notice here. Now, later on, we will summarize or relate it with the following given. But for now, we're looking at the graph. We can notice easily that it is indeed going upwards. That means that this specific line is increasing because nope, it's not going downwards. Okay, so this one right here goes upwards. Let's have one more example. Let's say we have this one right here. And again, it doesn't matter what point you start with, as long as you know the sign once you go to that direction. So I'll explain it now. So for example here, I would like to start with this point, and my goal is to go to this point. So I could either rise and then run or rise. It doesn't matter as long as you know again the sign when you do that specific movement. So from here, let's say that I'm going to the left, 1, 2. Since I went to the left 2 units, the answer here must be negative 2. I'll explain later. Next, to meet the other point, we will go 1, 2, 3, 4, 5, 6. 6 units up. So our rise is 6, our run is negative 2. So using the formula again, what we have to do again to get the slope is simple. Slope is equal to rise over run. So this will be 6 divided by negative 2. Always remember again class that if we're dividing two numbers of different signs or unlike signed, the answer should always be negative. So 6 divided by negative 2 is negative 3. I think it's pretty much easy to see here that the given answer, or sorry, the answer that we got is negative. So that's what we put here. So the slope is negative. As you can notice, it's not going upwards. Instead, it is going downwards. That implies that this line right here is decreasing based on its slope and the way the graph looks like. That's how it works. Let's have another example. Let's have this one right here. So we have 2 points again. It doesn't matter where you start with. So for example, I wish to start with this point right here instead of this one. Well, it's not that complicated. So let's say that I would like to start by going to the left. Since the direction is left naman here, it's not the right, it's automatically the run. And since the left side, that would make it negative 2. Then from there, I will go down 1, 2, 3. So since I went down, the answer there will simply be negative 3. And since that's it, basically, we can have our answer as follow. Slope is equal to rise over run. And since our rise is negative 3 and our run is negative 2, our run is negative 2, we can actually cancel out the negative signs here. And therefore, our final answer will be simply 3 over 2. And I would like to repeat again, it doesn't matter what point you start with or what direction you start with, as long as it is correct. Okay? So if you go to the left, it's negative. If you go down, it's negative. If you go up, it's positive. If you go right, that's positive. So that's something important for you to remember. Okay? Let's try another one. I'm sorry. Since this is positive, we can easily say that the slope that we have here is indeed increasing because it is positive slope. So we will summarize that better later. Let's say we have this one right here. Another example. Again, you can start anywhere. Let's say that I'll start with this point now, and then I want to go here. So what I can do is to go 1, 2, 3, 4, 5. 5 units as my run. Since it's to the right, it is positive. Now I will go down 1, 2, 3, 4, 5. So my rise is equal to negative 5. So using the formula again for slope, this will be equal to rise over run. So this will be negative 5 divided by 5. And since again, they have different signs, the answer should be negative automatically. So negative 5 divided by 5 is negative 1. That's how you work on it. And as you can notice, the slope is negative. At the same time, you can notice already that the line is going downwards. That's how easy it works. It's not meant to be complicated. It's just a matter of counting and directions. So let's try some things to think about. So we're being asked that when can we say that a line is decreasing from left to right? There are cases wherein you will say, oh, sir, it depends on how the graph looks like. That's actually true. But there are times wherein you don't have to necessarily solve or count anything or graph at all. Sometimes, given a certain thing, you can already identify if it is increasing or decreasing. So we can say that a line is decreasing if the slope is negative. And then we can say that a line is increasing if the slope is positive. That's how it works. As simple as that. These are the two things that you have to remember in order to identify what kind of slope you're getting. Other than being positive, we can say that it is increasing. Other than negative, we can say that it is decreasing. This time around, what we're going to do is we're going to graph given the slope and a certain point. As you can notice here, we have the point 1, negative 1. And always remember, this is your x sub 1. And, sorry, your x. And then your negative 1 is your y. So the importance of remembering how ordered pair works so that you will be able to easily plot that on the Cartesian coordinate system. So when we have 1, negative 1, so that our x is 1, so we will go here, but our y is negative 1, so the point must be somewhere right here. This is 1, negative 1. Now, one of the concerns that is going to be asked here is simple. How do you graph the second point in order to draw a line when you're given with the point and a slope? It doesn't have to be complicated again. All you have to do is to go back to the concept of rise over run. This one is easy because it's already in fraction. Basically, what I'm trying to say is that 3 over 4 is your slope. Letter M means slope. Okay? I would like to reiterate that for everybody. M means slope. So all you have to do here is to go back and plug in the formula rise over run. So what you will do is simply substitute that, or at this point, you will figure out the parts one by one. So let's just say that the first thing that I can say here based on the formula itself is that the rise is 3 and then the run is equal to 4. That's actually correct. So what will happen is that we will use this point right here that was given to us as our starting point. And then from there, we will either go up or down, left or right, depending on situation. In here, since the slope is 3 over 4, what we have to do is to go up 3 units. From here in the origin, we're going to go 1, 2, 3. And then afterwards, since the run is equal to 4, we're going to run 1, 2, 3, 4. So that means that there is a point somewhere here. And all you have to do next is to now plot those points by having a straight line. It doesn't have to be complicated again. It's just a matter of, what they call this? It's just a matter of knowing the directions and the signs that are in line with it. As we can notice here, the slope is 3 over 4. And it's easy to say that this is positive, and at the same time, it is increasing. Please remember that. Now let's go and have one more example. Let's say that we have here 1, 2, and then 2/5. So again, what you have to do here is simple. You don't have to panic. All you have to do is to plot the point first, 1, 2. So 1, 2 can be found on the quadrant 1. And here it goes. 1, 2. This is where you see 1, 2. And since the slope is also a fraction still, 2 over 5 is equal to rise over run. So that means that the numerator will rise and the denominator will run. Okay, so let's start with the point 1, 2, which is here. Since everything is positive, there's nothing to worry about. All we have to do now is, again, to start counting. Since the 2 is the rise, what we have to do is 1, 2. That's correct. And then let's try to identify the horizontal change, which is the run. We have how many units? 5. So from here, we're going to move 1, 2, 3, 4, 5. So what does that imply to us? Meaning to say that there will be a designated point on that location based on the slope that we are given. So moving 2 units up and then 5 units to the right leads us with another point located at 6, 4. Is it 6, 4? Am I correct? 1, 2, that's correct. And then what do you call this, 6 units to the right, 5 units, wait, yeah, 5 units to the right. It's now in 6-4. So these points don't mean a thing if you don't connect them with a straight line, because at the end of the day, the lesson again is linear equations in two variables. Make sure that your lines are straight, not like mine, but at the same time, make sure that you have um, you have arrowheads for your line, because that's an important detail. From 2 over 5 as our slope, it's easy to say that this is positive and it is increasing. Okay, please, if you're having confusions or problems with this, always make sure again, do not overcomplicate things. A positive number is basically a number or integer that doesn't have a negative sign. As easy as that. Because if there's a negative sign, that's no longer a positive slope. That's negative na. It's a different one. Let's have another one right here. What we do here first is, again, we start by plotting the point 0, 2, where 0 is our x and 2 is our y. And as you can notice again, our slope is none other than negative 2 over 3. This implies again that our negative 2 is our rise and our 3 is none other than the run. So this will help us out a lot in identifying the next point that is missing. So we start with our ordered pair, which is 0, 2. So that can be found right here from the origin. We're going to go 2 units up, 0, 2. So it should be there. Next, we have our slope, negative 2, 3. So our rise is negative 2. So that implies we're going down 1, 2. And then since our run is positive 3, from here on out, we're going to go 1, 2, 3. So there should be a point that lies right here. And that point is none other than 3, 0. So as you can notice, again, that there are 2 points now indicated, and all we have to do is to connect them using or with the help of a straight line. So doing so, let's just say or pretend that this is a straight line right here. Ayan. Connect those two things and we're good. As long as there's arrowhead, there's no problem with that. Again, we start by plotting the points 0, 2, and then from there, use the rise over run. And as you can notice, there might be or maybe a pattern already that you can notice here. But that's for the meantime. Later we will summarize it. So here you can already notice that the slope is negative because of the sign of the numerator. So slope is negative, thus this is decreasing. Okay, so that's how it works. Let's now proceed to the next example. We have here negative 5, negative 4, and our slope is 4. Now, I will explain this thoroughly, don't worry. So let's start first again with the point. Our x is negative 5, our y is negative 4. So we're going to start from the origin. 1, 2, 3, 4, 5 to the left since it's negative 5. Then we're going to go down 4 units. 1, 2, 3, 4. So it should be somewhere there. Here. So this is at negative 5, negative 4. Now, there are big concerns about givens wherein the slope are basically integers and not fractions. So you don't have to make it complicated. So here, our m is equal to 4. And actually, this is the same as 4 over 1. The entire reason for this is simple and not meant to be complicated. Because the slope here is 4, it's a whole number. This implies that it is also a fraction. Always remember that whole numbers have a denominator equal to 1. So whether um, Again, sorry, other than whole numbers, integers also. By integers, meaning negative numbers also have a denominator equal to 1. That's true for all. So the reason why I'm introducing this, so that when you see a whole number, you're not gonna panic like, what's the rise, what's the run if there you got a whole number or an integer. Always remember, again, if you have an integer, the denominator is always equal to 1. So this implies that our rise here is none other than 4, and our run is none other than 1. So from here on out, all we have to do is to rise 4 units. 1, 2, 3, 4. That's it. And then we run by 1 unit. So 1. So your point should be somewhere right here. It's located at negative 4, 0. Then again, we're just simply going to connect those two things, and then we're good. So this is how the graph will look like. And as you can notice, since the given slope is positive, it is increasing from left to right. Again, always remember, if the slope that is given is an integer, automatically the denominator is equal to 1. So let's continue to the next one right here. Now, what can we summarize based on those situations? The slope of a straight line given the graph is the measure of the ratio of the vertical change and the horizontal change. The slope, which is the vertical change, implies the rise, right? And it's important to take note that if we're talking about the rise, there are only two directions. It's either we go up or we go down, right? While for the run, it's either we go right or we go left. So the reason why I'm showing it this way, so that you will be able to summarize the concept. Meaning to say that if you're going up or going right, the sign will always be positive. While if you're going down or going left, the sign will always be negative. So that's how it works. And it's an important thing for you also to remember that, again, if we have a whole number or an integer, the denominator is always 1. And please, please, please be careful with this. Again, take note that if you have certain situations wherein you're solving for the slope based on counting, always remember a lot of things there wherein you might see something like this. Example, you might see something wherein you have a negative 1 over 2, right? You already know that here, what you're going to do is you will go down and then go right in terms of your movement, okay? That's something that you have to remember. When you see something like negative 1/2 or 1/2 or something like that, it's not giving you an ordered pair. It's not negative 1, 2. No, no, that's not how it works. The fraction is given, the slope is given in order for you to identify the next point. It's not the point itself, it's giving you the idea where to go next. Okay, so that's basically it. It doesn't have to be that complicated. You have to review here the positive and negative values. Again, up or right, that's positive. Down or left, that is negative. So to continue, let's go with slope of a line given the equation. So when we're given the equation, it's not meant to be complicated. So we're going to discuss today, since this is a video, is we're going to discuss the technique already. So let's start with our introduction. So there's something that we call as the slope of a straight line, which is the slope-intercept form. So we have it in the form of y is equal to mx plus b, where the constant m is the slope of the line and b as the y-intercept. Hence, it is called as the slope-intercept form. So for example, you have the following here, this slide right here. All of these are already in slope-intercept form. How was I able to say that? Not only are there two variables for each item, we already can see that the y's are alone on this side. But that's an important detail. The y should be alone on the left side of the equation. So the slope, it doesn't have to be complicated also. We are just talking about m, meaning to say we're not going to include the variable. So here, our m is simply 2. So here, m is equal to 2. For the second one, it's the same. M is equal to 2. Now, for the third one, do not forget the sign. Your m here is negative 2. Similar with the last example, your m is equal to negative 2. For the y-intercept, you also have to make sure to include the sign. I would like to clarify that. it is not positive all the time. We're just talking about the regular version wherein it could be positive, but if you substitute naman the negative value, positive times negative is negative. So again, what we're talking about as the b or the y-intercept is whatever it is, or the constant that is included there. So for example, the 8 here plus 8. So therefore our y-intercept here, or b, is 8. Similarly, plus 2, that is our y-intercept. Then here it's positive 5, so that is again our y-intercept. Then lastly, we have here negative 4. Since it's negative, therefore your b should be negative 4 also. So as you can notice, based on the given examples, we can also identify which is increasing and which is decreasing. So the increasing here are the first two examples. Why are they increasing? Because the slope is positive, while below the last two examples is decreasing because their slopes are negative. So that's how it works. So in here, it's not that complicated because it's already in slope intercept form. But if it's not in slope intercept form, we have to review it properly. So let's say that we have here the examples. Negative 3x plus y is equal to 7. 2x plus y is equal to negative 3. Negative 7x plus y is equal to 12, 9x plus y is equal to 22. To give you guys a heads up, the ones that I'm going to show here are just one-step solutions. While for other cases, you might need to apply the division property, but again, it depends on the example. As you can notice naman here in the given examples, the y's are already alone. There is no numerical coefficient there, so there's no problem. Your goal here is to move the ones with the x's, because again the goal is to only have y alone on the left side. So to do that, what I'm going to teach you is the technique which we call as transposition. Okay, so an example for transposition can be shown with the help of the first example. Transposition, let's use the first example. Negative 3x plus y is equal to 7. So what I will do is I will put negative 3x to the other side of the equation so that the y will be alone. When you do transposition, the sign should change. So from negative 3x, so you can see negative 3x, it will become positive 3x. And then the 7 is positive, so 3x plus 7. So I would like to say that again. Transposition implies that signs will change when you put it from one side to the other. So this is now in slope intercept form. So again, the answer here is no, it's not in slope intercept form. The slope intercept form version of this is basically, I'll just write here on the table. The slope intercept version is y is equal to 3x plus 7. So for the second one, we have 2x plus y is equal to negative 3. We want the y to be alone, so we're going to move the positive 2x to the other side of the equation. Since 2x here is positive, when we move it to the other side, it should change sign. So it will become negative. So y is equal to negative 2x minus 3. So that is our new equation in slope intercept form. So to do the third example, we have negative 7x plus y is equal to 12. We want the y to be alone, so we're going to move the negative 7x to the other side. And since it is negative, when you move that to the other side, it should become positive 7x. Then since 12 is positive, so plus 12. Y is equal to 7x plus 12. And then lastly, number 4, we have 9x plus y is equal to 22. Again, we want the y to be alone, so we're moving 9x to the other side. Here, this will give us y is equal to negative 9x plus 22. Again, the reason for that is because when you transpose, the answer or the term that we transpose should change signs. This is actually a showcase of the concept of the properties of equality, whether addition property or subtraction property. I just want to show that. So I will show an addition property example using number 1. Since we have here negative 3x plus y is equal to 7, the goal is to isolate the variable y. So we look at the one next to it. The one next to y here is negative 3x, this term, and we want to eliminate it. So we will simply look at the inverse of negative 3x, which is positive 3x. So we will add 3x to both sides so that we can eliminate it. Negative 3x plus 3x is 0, so you will be left with, again, the same answer as earlier. Y is equal to 3x plus 7. So this is APE, or addition property of equality. This is the application of the transposition. So I'm just showing it to everybody so that you'll realize where the technique came from. So I'll use item number 3 to show wait, sorry. Oh, item number 2 pala, tama. Item number 2 is the one that I will use for subtraction property. So how will it work? Same thing. Look for the inverse of the term next to the y variable, the one that you wish to isolate. So here it is 2x plus y is equal to 7. I wish to isolate the y there, so the 2x should be eliminated. Since it's positive, I'll subtract 2x to both sides. So the answer there will simply be y is equal to negative 2x. Why did I write 7? I'm so sorry. It should be negative 3. Where did I get 7? This should be negative 3. Oh yeah, I combined the two given. So minus 3. So that's how it looks like. Apologies for the mistakes. I'm a bit sleepy right now. So we can now identify the slopes and the y-intercept. For the first one, the slope is 3. For the second one, it's negative 2. For the third one, it is 7. For the fourth one, it is negative 9. The y-intercept is as follows. We have 7. We have negative 3. We have 12. And lastly, we have 22. So that's how it works. Okay? So that's how you that's how we work on the equations and identify the slopes given them. So the last examples that we're going to have is identifying the slope given 2 points. So wait, did it repeat? Yep, I think it repeated. Yeah, it repeated. Now let's go to the last one. Slope of a line given 2 points. In here, it's a bit difficult for others to remember, but this is something that is important for you to understand. The thing about here is that we're teaching you also how to label ordered pairs or given values. This is where we include the concept of what we call as the subscript. This is not an exponent, because if exponents, it's the one above the variable, right? The small number. This time around, we call them subscripts. These are numbers that are below the variable. So this implies labeling. Like for example, the first point, the first ordered pair, will have the x sub 1 and the y sub 1, because since it's the first point, so that's the first pair of x and y value that we have. And the x sub 2 and y sub 2, because that's the second pair of ordered pair that we have. And the formula is, as you can see, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. The reason for this is because, again, remember the formula earlier, the rise over the run. The rise implies the vertical change, whether up or down, and then the run implies the horizontal change, whether left or right. That's why we use the y's above below the x in terms of the numerator and denominator. It doesn't have to be complicated. Let's just start with labeling. So to make this easier for all of us, what I'm going to do is I'm going to label letters A, C, and G as our first points. So these will be our x sub 1, y sub 1, and then I'll use B, D, F, and H, these 4 points, as our second points, x sub 2, y sub 2. So let's start with our first example. Again, this doesn't have to be complicated. Our y sub 2 is 5. That's our second y. And our first y is 1. So that will give us 5 minus 1. And the answer there is equal to 4. And then for the next one, x sub 2 is 0 minus x sub 1, which is negative 2. You have to be careful there. You have to put a parenthesis so that you know what it looks like and how we simplify it. Negative times negative will give us positive, so this will be 0 plus 2, and that is equal to 2. Again, the reason behind that is because negative times negative 2 is positive 2. So since we have the value for the numerator and denominator, we simply divide. 4 over 2 is equal to 2. Let's do it for the next one. We have 8 minus 5, that is equal to 3. And then we have 4 minus 7, that is equal to negative 3. So 3 divided by negative 3 is equal to negative 1. So we also have another set of example. We have 3 minus 6, that is equal to negative 3. Then we have negative 4 minus negative 2. So this is the same as negative 4 plus 2. That is equal to negative 2. So we will have negative 3 all over negative 2. Since they're both negative, we can cancel the negative sign. We'll have 3 over 2. Then lastly, we have y sub 2 minus y sub 1. 1 minus 1, that is equal to 0. Then we have 3 minus 1, that is equal to 2. So 0 over 2 is equal to 0. So these are our slopes. So we simply have to know how to label properly our second point and our first point. Knowing how to label properly will help us out a lot in this concept. Now, in here, I would also like to give this out so that you will not be confused, since this is the last part of our lesson about slopes. We can notice that we have the following kinds. We have the positive, we have the negative. I mean, that's a fraction, but it's still positive. And we have a 0 as a slope. When the slope is 0, it doesn't go up, right? It doesn't go up because its numerator, which is the y sub 2 and the minus y sub 1, so it doesn't go up. That implies that this line right here, it will look like this. It's a horizontal line, and the slope is equal to 0. Now, you might be wondering, what if instead of the numerator or the vertical change, the vertical change, it is the horizontal change, which is the denominator, that is 0. So what if we have this kind of example wherein we have 3 over 0? This one will look like a vertical line instead. So if we have a line that is vertical, that is not a line that has a slope. That actually has a slope that is undefined. Why is it undefined? Because again, it is impossible to have a denominator equal to 0. So the 0 denominator makes it undefined. So if the numerator is 0, it's okay, but if the denominator is 0, it's not okay, it's undefined. So that's how it works. And I'm sorry if I'm mumbling a lot here. I've been sleepy, and yeah, I hope this helps as you guys try to cram everything with your review. So for the slope, you have to remember, again, we have 3 different ways of getting it depending on the given the graph, given 2 points, and given the equation. So that is our last learning target. I guess we were able to check that one out, and I think that's it. So good luck on your exams, and see ya on third term. Well, that ends this video lesson, and I hope you learned something new, or you were able to somewhat refresh your memory with things, and I hope this helps out. If you have more questions for clarification, you may maximize the chat box below. Let's just pretend that I'm actually a YouTuber who will comment or reply to messages in the comments. Who knows? Maybe I will. Maybe I won't. Who knows? But hope you guys learned a lot from these videos, and I hope you are doing well and you are able to rest. At the same time, you're not panicking. Just keep on learning, and hopefully math will go right with you, because at the end of the day, mathematics is for everyone. Everyone is a math person. Hashtag I am a math person. I'll see you guys. Always remember, what's up? That's respect.